Good morning, everybody. My name is Andrea Storto, and I work at the National Research Council in Rome. I will show you some preliminary results from assimilating CIMR brightness temperature into a simplified couple model. So the two main motivations for this work are that first, in the ocean communities, usual to assimilate geophysical retrievals with respect to brightness temperature, and this approach has been found quite suboptimal by numerical weather prediction because it introduces some cross covariances between background and retrievals. Another important motivation is about coupled data assimilation, which is expected to minimize imbalances and initial shocks and improve the use of satellite data through coupled observation operator. And CIMR appears an ideal instrument to test these ideas. So we base our work environment on a single column model version of ECEarth composed by NEMO 3.6 and OpenIFS plus LIM3 CS model. The system is located at the Papa Station in the Pacific Ocean and 50 degree north and maintained by University of Stockholm in the ECEarth consortium. The assimilation system is a variational scheme, incremental variational formulation, which includes seamlessly parameters from the atmosphere, wind temperature and humidity, and from the ocean temperature and salinity. Background error covariances are multivariate UF, and the system also includes simple background quality check and vertical superhopping. On the left side you can see profile of temperature variance, error variances for the atmosphere and the ocean, and vertical correlations on the right panel, including both atmosphere and ocean. Another aspect of our study is to the observation operator from CIMR that is based on MIRAS for the salinity sensitivity channel, the first channel, and AMSRE for the other channels. Forward tangent and adjoint models are taken from the RTTOV 13. However, we also try to simplify this observation operator, analyzing some surrogate model, in particular comparing artificial neural network using a large ensemble of training data and polynomial regression. And we found that both artificial neural network and polynomial regression of order larger than 3 provide very high accuracy, less than 1% error. In order to test the assimilation, we ran a nature run with perturbed atmospheric oceanic initial conditions and physics, and extract synthetic observation of in situ in the atmosphere and ocean from Radisson and Argo, and from CIMR, either as brightness temperature or geophysical retrievals. Preliminary experiments were devoted to understand the impact of the different observing network, so radius and Argo, brightness temperature, or retrievals from CIMR, and verification skill score that you can see on the top left panel together with the control run without any data assimilation indicate that the assimilation of brightness temperature outperforms that of retrievals for ocean parameters. And in particular, looking at the profiles of root mean square error on the right side, that brightness temperature data assimilation particularly benefit the skill score around the thermocline for both the temperature and salinity. As another result, we look at the impact of individual channels and found out that assimilating all the channels from CIMR together provide the best score. To summarize, CIMR mission provide an interesting way to test ideas of assimilating brightness temperature or coupled data assimilation algorithm, and preliminary results suggest that brightness temperature assimilation is effective. We just started this work. In the future we plan to have a sensitivity experiment about different observing scenario and coupled versus uncoupled background error covariances. Thank you for the attention.